This is the star and galaxy hopping. These are the low-tech skills for visual observations of the night sky. And to visually observe the sky, it's very simple. There's no electronic gate astronomy. There's no astrophotography. You just want to get a good telescope with a decent sized mirror or a decent sized lens. Either you get a Newtonian reflector or some refractor used for visual observations, good pair of astronomical binoculars, and usually just go out in the night sky and just look at the constellations and use your naked eyes. And you can use a combination of these particular tools. So a good primary or secondary mirror, actually a good primary and a secondary mirror, and an achromatic refractor, 2-element lens, so you get a nice sort of decent refractor. You don't need the 3 elements, using that for observing, not for doing astrophotography. Combination of viewfinders and telrads, eyepieces, filters, borrow lenses, Botanoff mask if you want to be able to get a nice collimation of your telescope. Our Sky Astro Instruments has this astronomer's hooded observing vest. There used to be another company that did that, but they went out of business. So I found our Sky Astro Instruments. A great star atlas, Stellarium, or the Pocket Sky Atlas from Sky and Telescope. Sky events, when you're looking for events taking place in the sky, either Sky Safari or Heavens Above. Red lights, red coverings for everything you use, particularly with laptops and flashlights. And of course, having a chair and a desk to put stuff around and a tarp to, of course, lay underneath your chair and your desk so you don't want to be on the grass. You know, all the basic things you need, of course, warm clothing and perhaps some beverages and snacks with you when you're out there at night observing under a cold sky. So the things for skills for visual observations, one thing, of course, is being able to study the sky, getting a decent star atlas, whether it's a paper atlas like the Pocket Sky Atlas, or having an app on your smartphone, or a software package like Stellarium. Studying the atlas so you understand the constellations, the shapes, the patterns. So there's the names and the lines, because the constellations form these line patterns. So you get the brightest stars in terms of the names, the brightness, because there's magnitude. If you have a small magnitude value, the stars are very bright. If it's a large magnitude, the stars are very faint. There's also the color of the stars, a combination from going from blue to sort of an orange color. Clear, dark nights between the twilights, and you look up into the sky and you see the stars night after night. So you look up at the stars, try to recognize some patterns. You go back to your atlas, you look up at the night sky, and you do that night after night. So you get familiar with what's up in the night sky and how it changes from night to night. And then, of course, being able to locate and identify the most common constellations, meaning the constellations we all know best, like Ursa Major, Orion, Sagittarius, and find the brightest stars, such as Rigel, Betelgeuse, Arcturus. And then, of course, you locate all the main stars in the best constellation. You find the brightest stars and the faintest stars. You can pick a constellation you can recognize every night, use that as sort of a marker to find your way around the night sky. You find the brightest stars in that constellation. You compare it with your atlas to see that the constellation you see up there, looking at the star patterns, you remember that from looking at the constellation on your star atlas. And of course, use your hands to navigate. Use your hands to measure angles at arm's length. And then you have your scope ready, and then you spend a night finding objects with your guiding instruments. And I have something called FTTV, which is first to telrad and then to viewfinder, because you look at something visually, then you compare it in the telrad, which is looking like at 4 degrees of sky. It's 8 full moons from end to end. And then going to the viewfinder to see a slightly small area of the sky. And if you find that little buzz spot, which is your deep sky object or a group of stars, then you can look at inside the eyepiece. So that's what I would call my goal heap. Go from low to high with the eyepieces in the focuser. I've tried it many times where I use like low power eyepieces in the focuser to look at it from a certain area of the sky to a small area of the sky, and then you apply that with the focuser and the telescope. Now, star hopping from naked eyes to the eyepiece, and then galaxy hopping where there are little to no stars. And then there's the magnitude in degrees during looking at the brightness of the stars in the night sky, and then measuring across the sky in degrees. And it's something as simple as just using your hands, such as using like 3 fingers to look at a width of the night sky, like 5 degrees, but you do it at arm's length. And then there's changes in the night sky, how the constellations change, going from month to month. So astronomy and sky and telescope are great, but I think the excellence would be with Stellarium, Sky Safari, or Heavens Above, because you can update that and it gives you sort of nightly events that are taking place. You can plan ahead. So getting a decent star atlas, you can go something is online. I don't know if anybody's ever seen this with the deepskywatch.com. They have sort of like a uranometria-like atlas, and you can download a very simple atlas, or you can download an atlas of extremely high detail, and you can get the stars, you can get the objects, you can get constellation patterns, the constellation boundaries, and then you can do something as simple as the right here with Sky and Telescope. This is power from Heavens Above. You get the basic star patterns, like here's the teapot, here's the great square Pegasus, over here is Cygnus, the Northern Cross, and you can, of course, get the W in Cassiopeia. The circles represent the common deep sky objects, like the double cluster over here between Perseus and Cassiopeia. Here's M31, and down over here is your Lagoon and Trifid nebulas around Sagittarius. Now, a good star atlas and a whole planetarium software, I like to use Stellarium a lot. I put it on my laptop and wherever I go. Nowadays, you have Stellarium version 21, so it gives you a lot of star catalogs. You can look what the night sky looks like ahead of time. And none of you have seen this. If none of you have seen this before, here's the Milky Way over here. You've got your cardinal directions. You get your stars. You can put in your patterns right there with the constellations. Nowadays with Stellarium, you can actually put up your asterism patterns. Now, locating and recognizing the constellations. Now, you go to a night sky like this, you wonder, how am I going to distinguish anything in the night sky? I see a bunch of stars, there's the Milky Way, so what do? Well, let's see if you can find certain patterns. Like over here, you see these 5 stars and a W. Well, that looks like that's going to be Cassiopeia. And then you got these group of stars here, which is the Pleiades. And then it looks like here, this looks like Taurus, the bull, because you see the star looks like Antares. And so I can just overlap the constellations and boom, there you can see the common name for stars. You get some objects in the solar system like Ceres, the largest asteroid, maybe a comet pops up. And look at right here, that haze right there looks like the Milky Way. I mean, actually that's here's the Milky Way, that's the Andromeda galaxy. So you can see how you can go back and forth and comparing those constellation patterns to what you see in the night sky. So again, here we've got, this is of course in the summertime, because you got Sagittarius over here. Here in the wintertime, there's Orion. So you get the constellation patterns. So it's very easy to go out in the night sky and not recognize the constellations. But if you look back and forth between your atlas and the night sky, you begin to see the certain star patterns that appear, like Scorpius. You got this boxy constellation, Ophiuchus, and then here, of course, is Cygnus the Swan. Oops. So, of course, you've got the Keystone right up there, and then over here you can get Orion. And then, of course, there's Gemini, and then, of course, you got these 5 stars that represent the winter hexagon. And those are the types of patterns that you'll be able to recognize night after night after night, so you can easily navigate across the sky. Now, important notes, I always say you get a basic star atlas and you study the maps of the night sky. So before you worry about deep sky objects, you want to get familiar with the stars, the constellations, the asterisms, which are just recognizing parts of a constellation. There are the boundaries. You won't see those in the night sky, but you'll see those on a map. So when you're looking for some Messier or NGC object, it might be on the boundary between 2 constellations. The Milky Way, where it is across the sky, usually get a blue sort of haze across the sky atlas. The North Pole, the North Star, Polaris, and then you got your coordinates of declination and right ascension. So this is like the latitude and longitude of the night sky. And then step 2, you go outside and see the stars and take the basic star atlas with you. So you move between looking at the sky and then looking at the atlas and trying to recognize star patterns. Of course, it's good to find the North Star, the Little and Big Dippers. You look for the star patterns beyond the dippers. You look, review, and compare between what you see in the night sky and on the atlas. And then always use red lights, because white lights are just bad. And then step 3, take out your hand and move across the sky from place to place, using parts of your hand to measure angles at arm's length. And then you can use your hands to help find other constellations, asterism patterns, and common stars. And then the fifth step is repeating this night after night, season after season. That way you can know these patterns in the night sky. It's easier for you, easier for anyone when they want to go look at some deep sky objects, whether it's nebulas or star clusters. So this is the typical night sky. Of course, you don't get the names of the star up here, and you don't see the cardinal directions. But in this case, I use the summer sky. So we want to find the bright stars of the summer triangle. That's Deneb, Vega, and Altair. And I draw a triangle around that to represent what we call the summer triangle. So there's an asterism right there. That pattern crosses several constellations. And we identified the three. We got Cygnus, we got Lyra, we got Aquila. This is Vulpecula and Sagitta right there. So we got two small constellations that are inside that, mostly inside that summer triangle. We can trace the handle of the Big Dipper right here, and we can take it down to Arcturus, which is the orange star, and down to Spica. And then we can make a left across the south here, across Antares to the Teapot. So good way to trace your way around the sky. And then we circle the Teapot. So I always look at the Sagittarius star cloud from here as sort of the steam coming out of the spout. And then, of course, we intersect the other bright orange star, which is Antares. And that way we can come across here and find, here we got Libra, and of course, here we got Scorpius. From Vega, of course, we can go towards the west and find the Keystone right there, and that's Hercules. And of course, you can track back towards Spica, and along the way, you find Scorpius and you find Libra. And then, of course, we can look for all the minor constellations. Here's Polaris right there. And if we familiarize ourselves with these two other stars on the other side of the Big Dipper, we can track that towards Polaris, but we can take it towards Cassiopeia, the W. And the W actually has sort of two V's. I call this the Western V, and this upper here is the Eastern V. Because you think of a W, it's like two V's put together. And this is the W pattern in the night sky. And we can locate all the minor constellations. So over here we got Delphinus, the dolphin, which is the closest to looking like the actual constellation shape. And of course, here we got Vulpecula, Sagitta. Here's Corona Borealis right next to the Keystone. Down here is Ophiuchus, and we got the serpent that crosses it. In between Sagittarius and Aquila, we've got, of course, Scutum, the shield. And here's the Milky Way along the side. And then you can use this any technique to try to find your way around the night sky. You sort of create sort of triangles, you find sort of letter patterns, and then of course you move along the constellation, creating lines and just tracing across the sky. When you connect bright stars together and navigate from one constellation to the next towards the brighter constellations and use those as a stopping off point to get to the lesser known constellations. Now, first to navigate the skies with a viewfinder or a telrad. Now, this is from the Milwaukee Astronomical Society. I like to use these here. So here is the curving from Arcturus to Spica. From Spica, you can head up north towards the bowl of Virgo, which has the Virgo cluster of galaxies. This is the Porrima star. And from that bowl, if you go from the center of the bowl up and to the right, you've got the Nebula. And this is in Leo. We got the sickle right here. And then if we go to the left of that and a bit above, go about halfway the length of that bowl and equal above, and we got this group of stars called Milavi 111, and that's sort of the hair of Coma Berenice, Queen Bernice's hair. And then here we got our Virgo cluster of galaxies. Of course, the Coma cluster is over here. Now, with these 6-degree circles, you can look at 6-degree circles, and that's like taking your pointer finger, and from the longest point, from the base knuckle to the first knuckle at arm's length, that's 6 degrees. So we look at the circle, this is 6 degrees. So you can go about 1, 2, 3, 4 of those 6-degree circles from Altair, and you can end up right around M11. It's an open star cluster. You can see it somewhat naked eye with a small pair of binoculars, and you're right in the middle of Scutum. So Scutum can be a hard constellation to see because it doesn't have a lot of bright stars. It's in the Milky Way. So you head a bit towards the southwest, and you can find that M11. Now, 6 degrees, of course, is 12 full moons from end to end. And we can do the same thing here. Here's the Big Dipper. So we got about 10 by 5 degrees. Here, of course, we got Altair, and if we go about 1 to about 3 6-degree circles from Altair, we reach what we call the little Cassiopeia, which is this M, and at the center of the M right here, that little notch star between the two upside down V's, you have the Dumbbell Nebula, and across the way, you'll come towards Sagitta. And over here on the right of Sagitta, to the upper right, is this little asterism known as the Coat Hanger Cluster. And there's a nice little open star cluster over here on its eastern side. And then here we have our Big Dipper. Then we got the circles going from Mizar and Alcor to Alcad. And there's actually a nice little triangle right here. This is 24 Canis Venatici. And if we go down a certain distance and go down even more, this is almost like 6 degrees here. So we can actually create a nice little stretched out triangle, and that fits with finding M51. And it's actually a littler triangle right here, just above that galaxy, above the Whirlpool Galaxy, or the Pinwheel Galaxy. So we got a triangle within a triangle, an asterism within an asterism, and then you can focus down towards that galaxy. And I put the 2 triangles right there. So if you have 2 equal these right triangles, one on top of the other, which is actually not 6 degrees, I'm sorry, it's more like 3 degrees. So that 3 degrees right there, that'll take you close to M51. And there's the star right there. Here's another pattern, of course. You can use set of reticles if you have something like I have, like for instance here, I have this sort of right angle Orion viewfinder. It's 9 by 50. And the reticle I have in there, when I compare it with Stellarium, it's about a 4.5 degree field of view. So I can replicate that in Stellarium. So if I look in the reticle right there, I can try to center my object in that 4.5 degree view. So it's smaller than the 6 degrees, but you can use that to go from one pattern of stars to the next. You can see that in the viewfinder and then sort of track your way up to certain objects. So here, going from, and this of course is Meroc and Mu Andromedae, and you can just go up to these 2 stars. And over here is Alpharez and Delta Andromedae. Actually, that is this star, not that star. So I should move that up here. So that's Delta Andromedae. And if you're familiar with Andromeda, you've got a pair here, you got a pair here. So you count 1, 2 pairs, go from Meroc to Andromedae, and then double that, and it'll take you further up towards the Andromeda galaxy. And boom, you'll be able to see that galaxy in dark skies that is naked eye. Over here is Perseus. So we got the Gamma Perseus star, and of course the 1 6 degree circle from here to where the double cluster is. You can find that double cluster. It's sort of halfway between this star and the eastern end of the W of Cassiopeia. And again, it's that long, that distance between the 2 base knuckle and the first knuckle on your pointer finger at arm's length, that's going to be 6 degrees. And then here we've got the Stargate and the arrow. So if you're familiar with Corvus, you can do again a single 6 degree circle, overlap yourself to the arrow. At the tip of the arrow is the Stargate, and from there, just about less than half of a 6 degree circle, you're going to find the Sombrero Galaxy. So using circles at different sizes is very useful. So I don't know how many of you are familiar with this. You got to do this at arm's length. So the pinky nail, the pinky is 1 degree. The 3 fingers is 5. The fist is 10, 15, 25 degrees. And when I mentioned the pointer finger, you can use 3, 4, and 6 degrees. And with that, you can do any combination, whether an object is 7 degrees from another object, 8 degrees, or 12 degrees, or 30 degrees. You can move around the sky in multiples of these sort of hand widths, like 2 fist widths from an object, or 3 fist widths from an object, or 2 fist widths and 3 fingers, without worrying so much about right ascension and declination. Not that that's not important, it is important, but this is being able to navigate around the sky. So if you simply just spread out your fingers in a V shape at arm's length, you can go from one end of the Big Dipper to the other. And of course, it's 28 degrees, of course, from the pointer stars here that are separated by 5 degrees each. And then it's all the way up to the Polaris star. And you can see how you can take 1 fist width and 2 and 1.5 spreading hands, which is at 20 degrees at arm's length. That way you can go from Meroc all the way to Polaris. There's also a technique where you go from Merrick to this other star right here, and in the same direction, you double it. You can sort of find the M81 and M82 galaxies. Actually, I'm sorry, it's from this star to Dubhe, and then it's way over here, because that's closer towards the head of the bear. So that's opposite from the handle of the Big Dipper. So here's Hercules, here's the keystone. And we can go from the top star of Rezulgathi at the top of Ophiuchus. So we can find our way, if we know Ophiuchus, we can come over here to this star in Hercules. This is the north right here. And I think I remember right, the east, no, the west is down. So this is 6 3/4 degree, and that's 7 1/4 degrees. So this is sort of like, in one way, you can have like 4 width fingers that represent one end of the keystone, and then slightly over one from the base knuckle to the first knuckle in your pointer finger, and then probably out in your pinky, and that way you can get the stretch of the keystone itself. And then, of course, you go from there to Rastaban at 16.5 degrees from this upper right, this upper left star right here, looking due north. That's going to be towards the east. It will take you towards that bright star. It was sort of the eye of Draco the dragon. And then from Cor Corelli, you can curl eastward around and go back to that same southwestern star in the keystone. That way, if you know where the keystone is, you can find your way towards the dragon, go your way down to Ophiuchus, and go all the way to Coma Borealis. And from there, you can find the head of the serpent. Now, picking asterisms from the constellations. So right here, we got the fishhook and Scorpius, the teapot. We got the milk dipper right here, which is sort of at one side. Then we got the Terabellum. Then we can compare that with the constellations. And the teapot is the easiest area to recognize a constellation. When you get a certain number of bright stars within a section of a constellation, you treat that as an asterism, as a simple pattern, and be able to navigate around the night sky towards the other constellations. So this is Corvus. So we got the arrow, the stargate, and the jaw. So we have 3 asterisms right here. And of course, we're picking out the asterisms, and with the help of the Telrad, we can sort of use those circles to go from one star to the next star. And this is where we get into Telrad. So there are 3 circles. The inner one is a full moon. The second one is 2 degrees. The outer one is a 4 degrees. So it's like from 1 full moon to 4 to 8 full moons. So you get it in there, you can go from, and of course, if you get a viewfinder that gives you a 4.5 degree field of view, you should be able to see these 3 asterisms. You go from the arrow to the stargate to the jaws, and from the jaws right here, you point down towards the teeth as a line, and boom, right there, there's M104. There's the Sombrero Galaxy. And there it is up close. So there's the Sombrero Galaxy. And the 7 patterns I like to use are the lines, triangles, squares, circles, trapezoids, numbers, letters. And I should add an 8th one, which is basically polygons, because you can basically have something like hexagons or pentagons when forming geometric patterns. So I actually should say it's actually 8 patterns rather than the 7 patterns, because you can use polygons. But most of the time, you're using lines, triangles, squares, circles, trapezoids, numbers, and letters, because there's something called the 37 cluster in Orion, which is an optical open star cluster. And it looks like the numbers 3 and 7, but those are really our asterisms. So you can see what it is. And there's the north and the east. Actually, that should be the west right there. So that's actually the west. But between there, that's 18.7 arc minutes. So you can see how that can fit inside that circle right there. So if you find this trapezoid a bit beyond, if you go from the jaws, these 4 bright stars as the trapezoid, eventually you're going to pass along and come right across the Sombrero Galaxy. And you should be able to find these 3 stars that are stretched out below M104, and that will be your sort of your triangle that can somewhat point you at least towards the west end of M104. And I actually should have made this towards the west here rather than the east. So I need to correct that. So navigating with star clusters, what you can do with star hopping, you can do with star clusters. So of course, optical or visual, they can be sort of a type of asterism depending on the open star cluster. Of course, the coat hanger, I've heard this referred to as the coat hanger cluster, when it really it's just an asterism. And then of course, over here at one end is going to be an open star cluster, NGC 6802. So you can use some clusters or asterisms to find other asterisms or other clusters. And that way you can navigate around sort of the dense area of the sky looking for planetary nebulas or globular clusters. Here it is up close. And I don't know if any of you can see it. It's pretty hard to see, but it's this group of stars down here on the end. And it's about 17 arc minutes and 1441 arc seconds. So it's less, so it's a little over half a full moon width from 7 Vulpiculae here on this end of the open of the coat hanger cluster towards the open star cluster. And those are the groups of stars. I got that directly from Stellarium. Stellarium provides a plugin where you can do a telrad, and you can adjust the size of your sky to look like what it would look like in the eyepiece with Stellarium itself, at least for the star field where the objects are going to pop up. This is Cassiopeia. So we look at an area right here so you can see how we use the telrad. So if you look at the circles, you can navigate based on how many outer circles or middle circles or inner circles, whether you're going north or south or east or west with respect to Cassiopeia. So this is looking up close. So we got the Sailboat Cluster here. We've got NGC 103. There's the Starburst Galaxy. So we use the pattern right here. And we have to realize that we want to put a bright star. When we think about the outer ring, the top will be 0. And if you go counterclockwise eastward, you go from 0 to 90 over here to 180 at the bottom. So on the right is 90, bottom 180, and the left is 270. You try to put a star at one of these positions. And don't worry about north, south, east, west. It can become confusing sometimes with looking towards the north versus looking towards the south. I would focus on the asterisms when you recognize a constellation, and then look for star patterns. So here you can see I have sort of 2 triangles that are overlapping. I got a tripod of stars, and you can see from where Navi is, I can go from, let's say, basically about 1.5 of the large circle above Navi and about half a full moon towards the left. And we found, boom, we're here, we find the Sailboat Cluster. Now you should be able to find these 2 stars over here towards the left. You go north for about, I say about 3 full moon widths. And right here, we got the K Andromedae star. And then if you go along, if you sort of take that distance and go towards the, up here towards the upper right, which I think is going to be towards more like towards the northwest. This is 12 Cassiopeia, and you sort of take that 1, 2, let's see here, that's 3 full moons, 3 full moons. This is going to be like more like 1, 2, 3, 4 moons. And here you have NGC 129. And then you come down here for 1, 2 full moons. You got this Hipparcos star. You have this sort of, right here, you got this trapezoid. And then from this Hipparcos star, 2876, you can take this all the way to 1, 2, 3 full moons. You get back to the Sailboat Cluster. Now, going between this star and the Sailboat Cluster, you will find this, this open star cluster, NGC 189, and it's a little bit over halfway from there to 12 Cassiopeia. So if you go a little more than halfway above, you'll find NGC 136. You go back to the Kappa Andromedae, and you can go a bit towards, say, 1, 2, 3, 4, 5 full moons, and you end up with this pair of open star clusters, NGC 133 and 146, which is going to be towards the east and northeast of the K Andromedae star. So you can see how you can navigate around with star patterns. You can circle around star groups, and you can, and I like to call this the Cassiopeia Hexagon, because you got a nice concentration of open star clusters to observe around a pattern of stars. And this is around Navi, which is that central star in the W. Now here we got this sky, and of course we got our asterisms. And of course, under fairly dark skies with minimal light domes, depending on your vision, you can observe the double cluster in Perseus as a naked eye object. There are the bright stars, and then there's the star patterns, and then you have the visible clusters. So I would start, so you could start off with trying to find sort of like, here is Auriga, I call it the winter oval. Here's Perseus, and in between the two, if you go sort of halfway between Capella and Marfak, you can find that, well, this is actually the double cluster is down here. This is what I call the M&M double cluster. It's a nice group of stars to observe, because the other double cluster, there's actually two double clusters. There's the bright one we have down here, and then there's the M&M double cluster right there. So there's actually two double clusters you can find in Perseus. This is more of a, this is not really a naked eye object unless you're in very, very dark skies. And probably with a little help from a viewfinder, they do tend to sort of come right out for observability in fairly dark skies. Now here, of course, is Auriga, and this is what I call the winter oval. There is the east and the north for perspective of the cardinal directions. So we have lines of clusters, we have clusterings of stars. Triangles tend to be the best indicator. I sort of cut this in half between where I have a lot of star clusters on one side, on the southern half of Auriga, versus the fewer star clusters on the north side, at least the clusters that we can see with a small telescope. And then we have a triangle of stars right here. We got another triangle of stars down here. So we got a few triangles. We use those triangles to localize, of course, our three, what I call the Messier trio in Auriga. We got M37, this is M35, and then M36. We got the salt and pepper cluster of January. There's the pinwheel and the starfish cluster. That's actually M35. And so it's M37, 30, 36, 37, and 35. We got the letter Y cluster. It looks like the shape of the letter Y. And so we get the bright stars, we get the look for the star patterns, we find the visible clusters, and we can remember the sizes of the Telrad circles to guess the distances by angles, whether it's by a full moon, 2 degrees, or 4 degrees. The full moon being about half a degree of sky. So getting help from other constellations for star hopping. So basically getting a little help, let's say, from between, of course, Canis Minor and Orion, going halfway between the two, you can sort of overlap and find the least, a very dim, well, it's a dim constellation, Monoceros out in West Texas. It's probably a lot brighter, but you got a lot of dim stars here. You don't have anything as prominent as Procyon or Geomesia or Mintaka or Saiph or Betelgeuse. Here we got this sort of inner region of Monoceros down here. This is the unicorn. Here's the forward leg. Here's the north and the east. So if we go from the belt right here, we can come across sort of the bright star right here. That's 8 Monoceratus. It's one of the bright stars. And if you go between this star and that star at the top, sort of what I call the head star, you can find a lot of planetary nebulas in here, what we call the Minkowskis. And you can form a triangle between 6 Monoceratus, 8 Monoceratus, and this star right here, which is to the west of the, I believe that's the Rosetta Nebula right there. So you get this nice triangle. And that way you can navigate around the constellation, because that's the biggest part of Monoceros that's easily identifiable. And dealing with constellations that are hard to observe when there's light pollution, you can always use a neighboring constellation as a guide. And then you can apply circles in the Telrad to localize and triangulate groups of stars to locate star clusters. Sometimes you can use fractions within the circles, like a quarter of a degree or a third or half or 2/3 or 3/4, whether it's 2/3 of the 2-degree circle, the middle circle in the Telluride, or perhaps half of the outer circle, or maybe a third of the inner circle. It's sort of a rough estimation. You might be off a bit, but if you can get it within the area, at least equal to any of those 3 circles within the Telluride, generally you'll be able to find your deep sky objects. At least as being able to see it at low power, perhaps in an 8 to 10 inch telescope. Now, using all the 4 steps, you can do something like right here is Sirius, the dog star, and this is the head of the dog. So of course, here we got the Seagull Nebula, not that you would actually be able to see that naked eye, unless you have a special filter with some telescope with a focal reducer with a wide field of view. I call that the dog's head because you can distinguish the 3 stars here to the east and to the northeast of Sirius. So you can create a T pattern between here, of course, is the Theta star, Canis Majoris. And you can go about 4 degrees and another 2 degrees to Avery's Island, which is a open star cluster over here. We got this nice sort of bending of stars that sort of points towards it. And then an equal distance that will take you up above the heart-shaped cluster. And then you can form sort of a step ladder pattern in which you can go from one open star cluster. You either go northeast or go northwest or northeast or southwest or southeast, and go in a diagonal direction where you can see overlapping star clusters that are close together. Right there, that is the double mint cluster. You can at least find that if you can't see the rest of the Seagull Nebula. And right there, there's Avery's Island right there. And we get this sort of T-shaped pattern within that open star clusters. Open star clusters have particular patterns. And you can find that. You can find the double mint cluster. You can backtrack about a full moon width, perhaps maybe 2 full moon widths using the Telluride. Always guide between the Telluride, the eyepiece, and what you can see with the naked eye. And then from there, just head about an equal distance north and be able to find that stair step of the heart-shaped cluster, and then going for about probably about 3 degrees going to the northwest. You can make it all the way up to NGC 2302 right there. So always use large patterns at low power. Use viewfinders before putting the eyepiece in the focuser, and then using a stepladder effect with 4 or 6 degrees, again, using that distance between the 2 knuckles that are the furthest, as you can see here with the finger. You can easily navigate around and look for these open star clusters, particularly around the dog's head. Now, the technique can be applied to find star hoppings to find some nebulous deep sky objects. So constellations are important. Then you use those asterisms within the constellation. So we got Venus's mirror right here. We got Orion's sword. We got the belt. And right here, of course, we have Orion's triangle. And alternate positions on the Telluride, so like 45, 135, 225, and 315 degrees. So if you think of the circle, we go from going towards the right, towards the east, 0, 45, 90, 135, 180, 225, 270, 315, and then back to 0 degrees. And then going to the left or right or above or below around that circle. So you can see here, we have Alnitak, which is the southeastern star right here in the belt. And we put it right around, let's say that 135 degrees. And if we go, let's say, to the upper left over here, or let's say we're going in a northeasterly direction for, let's say, for 2, perhaps, about 2.5 degrees, then you can move your circle, perhaps another circle width, and then find yourself M78, the reflection nebula. Now here I have it with Sagittarius. So here we get the Lagoon Nebula that you can see with the naked eye. There's the Sagittarius star cloud. There is the M7 down there. So it's constellations with lots of stars. It's just a lot of patience and practice, because if you're looking at the Milky Way out in West Texas, you don't see a lot of stars. One of the slides I didn't put on was dealing with light pollution, because if you're dealing with light pollution, you're going to be dealing with probably just the stars inside the teapot. You won't see all these thousands of other stars. You see here are hundreds of stars. So it's even more important in light polluted skies to trust the Telrad and using your hand with sort of the fingers that I mentioned with the degrees to move from one position to the next and get into the general area in which you can try to find and perhaps see some of the brighter deep sky objects when you don't have a lot of stars available, when your border skies are more towards the larger than the smaller numbers. And you want to look for any interesting stars. You navigate around a common asterism, which is sort of like a core of the constellation. And then you look for interesting stars like binaries or variable stars. You guide your way to finding the bright star clusters, and then sort of navigating, creating your own asterisms. There's one down here I like to call the sea mantiny because it can help you find some of the Messier globular clusters down here between Escella and Cos Australis at the bottom of the teapot. And then that way you can locate fainter and fainter deep sky objects. So here I'm going to show the teapot in a different orientation. This, of course, is going north, is above, and to the right is west. To the left is east. And here, again, this is all within reasonable use of your hands. So just remember the fist width is 10 degrees. So you can go from the top star Polis, you can get across a Sagittarius star cloud for a little over 5 degrees, about a little over 3 finger widths, and you're at the Omega Nebula. You go for about 2 1/3 degrees. There's the Eagle Nebula, which is about maybe 1 1/2 finger widths. And then a fist width going south of the Eagle Nebula, down to the Trifid Nebula. And between the Trifid and the Lagoon, it's just over 2 full moon widths. And it's 4 degrees from Polis to Lagoon Nebula. And then it's 6 degrees, which is that long distance between the base of the first knuckle on your pointer finger from a nozzle heading sort of generally northeast towards the Lagoon Nebula. So that's a way you can use these nebulas to navigate around the sky, to do a bit of nebula hopping. Now with clusters and nebulosities, right there we can form this nice triangle with Shala, the star, and the stinger. In the middle there you find Ptolemy's cluster, M7. Between Shala and Seth, that's about 2/3 of a degree, so little over a full moon width. Then you have a triangle of stars right here. So it's 2 1/2 degrees to the northwest towards this triangle, and then another 7 2/3 degrees. So basically somewhat between using your thumb and the base knuckle to the first knuckle and your pointer finger, and you can go towards Zami Dimara, which is sort of opposite from Laseth along the stinger. And inside here you have your bear claw or the cat's paw nebula. And then you can see the distance going towards Larawag up here, and then going back towards the bear claw. And inside there you can at least see there's actually an open star cluster in there. So you can recognize the open star clusters in these nebulas if you can't see the nebulas themselves. And then around there is going to be the Lobster Nebula, which is about 2 degrees going towards the northwest of the Bear and Cat's Paw Nebula, which is like 1 1/2 finger widths. So right there is the Cat's Paw Nebula right there. And if we see where we're at here, so this is actually right around the area here that from the Cat's and the Bear Claw Nebula, you actually will find these sort of patterns of stars. You see these sort of zigzag patterns of stars right here, sort of halfway between Laseth and Zamidi Mura. Right there, if you see these sort of zigzag pattern of stars, you get these 2 stars in the inner circle. And from these positions here, going towards to the upper right, from the lower left, you can locate what's called the Butterfly Nebula, or the Am Nebula, which is a nice little small planetary nebula. And it's about halfway between Laseth and Zamidi Mura, between the star here opposite from the end of the stinger in Scorpius. So galaxy hopping, it's useful when you're dealing with lots of galaxies and very few stars like Leo, Ursa Major, and Virgo. You can star hop at low to low medium power. At medium power, at skies of 1 degree or less, you get fewer stars. So the galaxy hopping, I think, takes over, and you can use your 7 patterns of geometry and characters to navigate around the sky, navigate between pairs of galaxies, groups of galaxies, and clusters of galaxies like you would with globular clusters. And there will be dark spaces between the galaxies, even at very high power. So you're more looking at patterns of galaxies rather than patterns of stars. So for the galaxy hopping, in the case here, we got finding where we have M31. The Meroc, if you block out the star of Meroc, you can get Meroc's ghost over here, which is like it's basically a faint elliptical galaxy right next to Meroc. Just blot out the star in your field of view. And again, from Meroc to the Mu star, you double that distance, you go up to M31. This is crossing over from the star to galaxy hopping. So right here, of course, we've got Cetus, the sea monster. You go from Algenib, and you can head straight south towards Neb, Kaitos. There's Fomalhaut, Menkar. You can, of course, take sort of the curve here in the bull's face, his nose, and then point directly towards Menkar, which are the noticeable stars in Cetus. And in Cetus, of course, going from the Gamma to the Delta star, and then it's just a short distance within the Telrad of finding M77 in Cetus. Of course, you can take the 2 stars here from Markab, the star to the lower right, which is the lower left, which is the southeastern star in the Great Square. You can go across and find the head of Cetus, and along the way, you find this top star. I think this is Eta Piscinum, and find M74. And there it is right there. And of course, you can always have an atlas to help you out if you want to know the star patterns when you take it out at night. So there's M74 there. There's M74 from the Delta. That's M77 from the Delta star, Delta Ceti. And this is, of course, Eta Piscinum right there with M74. So it's less than 1 degree from either star to the east of either Delta Ceti or Eta Piscinum. And that's like using the central ring of the Telrad. You go just 1, 2 circles. Now, this is the area of the sky where we have Virgo, and right here we've got Leo. We can pop up the constellations. You get your asterisms. So we have the Great Diamond. We have Ptolemy's Triangle. We've got the kite. We got the trapezoid. We have the sickle. We have the sail with Corvus. And right there are your galaxies that you can get out of Stellarium. Different colors are for between ring galaxies, active galaxies, radio galaxies, and regular galaxies. And you can actually sort of pick them up. I call this the Virgo Corvus bridge. And then there are clustering around major galaxies. These are actual clusters, the Coma, the Leo, and the Virgo cluster right here. And there's actually perspective in terms of the distances of these clusters, these galaxies of clusters in millions of light years with respect to each other. And it gives you sort of a 3-dimensional perspective as when you're navigating around the galaxies, you know which clusters are further from other clusters and how far are they from each other. And of course, the group, I consider the groups to be sort of like you get groups within clusters, you get clusters within superclusters of galaxies. And you realize the patterns of the brighter galaxies are non-uniform. We got groupings and we got galaxies that are sort of spread out. And I always say the Messier catalog, if you're doing the Messier marathon, it's a great way to practice navigating around the Virgo cluster of galaxies because they have their own way to sort of zigzag around here. This is from a website as a reference. So you do at the start, there's the end. So you sort of starting from M77, you're going up north to Andromeda, and then you're sort of zigzagging around. This is very good because you can learn about star hopping. You can master your skills at star hopping. You can master your way around finding constellations and asterisms. And if you want to do this in one night or several nights as a marathon, practice, practice, practice. It's sort of like being baptized in fire when you're learning about and mastering star hopping. That way you can really know were to look up in the sky and realize, oh, that pattern of stars, I know that pattern of stars. It's such and such constellation, and there's that star and that star, and I know where some objects we can observe in that particular constellation. Now, here is your general layout of the more popular galaxies, the brighter ones. This is Mercurian's chain. This is Vendomeatrix. There's the Nebula, the sort of the tail of the Leo. There's Coma Berenice, so M111, Meliot 111 is up here. You go down here towards, so actually towards the lower left is going to be Spica. Down here is M61. And here we get the sort of the layout here of the Mercurian's chain, which is less than 2 degrees across. So you can fit those galaxies within the middle circle of your Telrad. It's actually like 1 3/4 degrees. So I always find the Virgo cluster to be the best example in training your skills when you're trying to take what you learned in star hopping and going to galaxy hopping. So this is your immense array of galaxies. It can be overwhelming, but the best thing, of course, is the method you can use when using the Messier marathon. So we go from the Nebula, we go about 6 degrees to the east, and boom, right there is your 6 Coma Berenice. The M89 galaxy will just be to the northwest, the low power field. There is M99. Then you find 2 mid-6 magnitude stars right there. It'll take you to right there to M100. And then, of course, you're going to be moving a bit north. And so that takes you all the way up to about, going about, let's see here. You take the 2 mid-6 magnitude stars, the mid-6 magnitude stars to the east-northeast, and you point the way to the Messier 100. And then from there, you move about 1 3/4 degrees north. And this star here is 11 Coma Berenices. Circle that. And there is M85 right there. And then you go across the sky, and this takes you to about 4 degrees east of Messier 99. And you can go across here towards M88 and M91. Then from Vendomeatrix, you can go to the star right here, which is a double star, 34 Virginis. And then about 1 degree to the south, a little bit, is about 41 Virginis. So actually, this is about, you move to the north, you go 3.5 degrees to find the double star, 34 Virginis. And about 1 degree to the south is 41 Virginis. And about 1 degree to the southeast is going to be a pair of galaxies over here. And that's down here, which is NCC 4762. You can take the 2 stars to over here, and you get NGC 4647. And there's NGC 4762 and 4754. And you can actually curl around these stars, and it'll take you right around to where we have M60. And about 1 3/4 degrees to the south-southeast of 41 Virginis is going to be 34 Virginis. So we backtrack a bit. We have right here 34 Virginis, and we got 41 Virginis, and so we can backtrack towards the stars, and we curl around towards M60 because you can treat this as a sickle. Right here, you can curl around towards these stars, and then you go for M58, which is right here. It's a little over 2 degrees to the west-southwest. And a low power field, of course, you get an NGC 4647 to the right of Messier 60, and about 0.5 degrees to the southwest is Messier 59. And a 1/4 degree below that is NGC 4647, is NGC 4638. And a little over 2 degrees to the west-southwest, you locate Messier 58. The reason why you find all these little NGC galaxies is that it helps you. I mean, if you don't know the names of these stars, if you find this star here, you can find these 2 bottom stars here, and it creates this nice little triangle. So you can go, let's say less than half the distance going straight down towards these pair of stars. And then, of course, from here to here, it's going to be less than 4 degrees, 3.5 degrees. and you can take it towards M60. So you can use these two stars to line up and just simply continue down towards the southwest to find M60, and then you can find all these galaxies here. And then it's not much of a big leap to go a little bit towards about half a degree towards the west and finding M59, and there's M58 right there. Now we continue on, and then of course down here we got some groups of stars. We got another group of galaxies. So we move to the southeast of Messier 58 right here, and we have the Siamese galaxies about 1 1/3 degrees to the southeast. Then we move less than a degree to the northwest. We find Messier 89 right there. From Messier 89, we can go, of course, to the northwest about 2/3 of a degree and find Messier 90. And if you go about 1 1/3 degrees, you go from Messier 89. From Messier 90, actually, you can go about a little over a degree to the west-southwest, the Messier 87 galaxy. Or from Messier 89, you can actually track that also about 1 1/3 degrees to Messier 87. And from Messier 87, it's just about 1 1/3 degrees. So it's about all the way towards where we have Messier 84 and Messier 85 as a galaxy pair. And in that galaxy pair, those are going to be the brightest galaxies you see in Mercurian's chain, which is just over around 2 3/4 degrees. And what you can do now is that you can actually trace these stars and go right back up to 30 from, let's see here, from Messier 60 right here. Actually, this is the Mercurian's chain. You can actually trace these stars right back up here to this star right there, which is, of course, your 6 Coma Berenices. And that's about 3 degrees to the west of Messier 84 right there. So if you go 3 degrees from Messier 84, you can track back to Coma Berenices. Now here we go back to NGC around where we have Messier 60, and we can head about 6 degrees south, and we can follow this down towards where we have the Virgo C asterism, and this is 30 Virginis right here, and that will trace as a nice little S, a little C right there as we go from this star down to this star, down to this star, and it can track us all the way down to here. And this is going to, if you follow these stars down here as a circle, you can then, of course, find this star and that star along the circle, and you can triangulate about 2 1/3 degrees from this star, 31 Virginis, and right here, this is 30. This is actually 30 Virginis right here. This is trying to remember, but this is 31 Virginis right up here, and this is about 2 1/3 degrees. Actually, this is 31 Virginis over here. This is 2 1/3 degrees towards the west, and here is 2 3/4 degrees bit towards the south from 30 Virginis. This is 30. This is 31, and from these two stars, from here it's 2 3/4 degrees south to south of 30 Virginis towards this galaxy 4535, and then here this is from 31 Virginis, and then you go 2 1/3 degrees towards the west, and right here you have, of course, NGC 4535, which is known as the lost galaxy of Copeland. And you can just go over a degree to the southwest of Messier 49. And here we don't have Messier 61 on this list, but you do have sort of a 5th magnitude binary nearby. So you can compare the view of the appearance in the viewfinder with a 4.5 degree field of view. You move the Telrad 4 degrees south of Messier 49. So this is just a 4-degree hop down to Messier 61. And Messier 61 is going to be at 1 1/4 degrees south of a 5th magnitude binary, which is 16 Virginis. And that's going to be sort of the bright star down there towards the south end of the bowl. And I thought I had Messier 98 here. It's going to be in the area here, but this is sort of the zigzag pattern they use when in the Messier marathon to navigate your way around the galaxies. Galaxy hopping can be pretty tricky, but you have to practice with the Virgo cluster. And again, use your fingers for 3, 5, 2 degrees, using 1, 2, or 3 finger widths at arm's length. Okay, so galaxy hopping from Pegasus to Andromeda. So these are our galaxy groups there. I call this one Aretitas group because there's a nice group of galaxies near the one Aretitas star right here in Aries. So from Pegasus to Andromeda, I draw on the celestial meridian. There's the north and the west below. So we have our galaxy groups. So you see that the great square of Pegasus is not perfect. It's 14 degrees from Alpheratz to the southwest to the southeast star. And then on the western side, it's 13, 16, 14 and a third degrees. Going from Alpheratz to the star here, that's slightly over 7 degrees. And from this star to Meroc is over 8 degrees. You can go 8¼ degrees to the northeast, to the northwest. From this star here, the northwestern star in the great square Pegasus, and you can find NGC, that's 7331 right there, which is the Dirichlet group. And actually, Stephen's quintet is just over here in these little groups of around NGC 7331. So it's a nice group of galaxies to observe. 4 degrees from Meroc to the central star, and then 7 2/3 degrees from Meroc to Andromeda Galaxy. That's simply going from Meroc to this star and then doubling it to the center of Andromeda. And then it's 14, 24, and 25½ degrees when you want to go from NGC 7331 to Andromeda, or from the northwest star of the Great Square to Andromeda, and then Alpheratz heading northeast 14 degrees to Andromeda. So you got many methods of stars and galaxies to find your way from Pegasus to Andromeda, from the Dirichlet group to M31. Now, looking in a telescope, you have to realize with a refractor or a reflector, what you see on a map from an image may be different from what you see in the telescope, because north, south, east, and west can be reversed. So this is the orientation which you can see Andromeda with respect to north and west. So there's a change in the appearance of the telescope, particularly as the image can change its view as you flip from west to east, or from east to west. The reflector usually flips and reverses an object's image. Well, of course, that helps when you have an eyepiece in the reflector, whereas a refractor makes the image look upside down. Here we get the flipping of just the west direction without flipping the north direction, whereas the other image here, we flip both the west and the north, upside down and inverted. And then here, we get north and west. So west is in the same direction, but we flip north. So going from the north looking up to north looking down. So it gives you a perspective of how the Andromeda Galaxy will look. So you have to be aware when you look at certain objects, you may have a picture of the object with north and west in the right orientation, but you'll see the object differently depending on the type of telescope and whether you're seeing it from the eastern part of the skies to the western part of the skies. And then hand navigation, just to remind the hand navigation that you're using to stretch out your arm. Remember to do this at arm's length. So 25 degrees when stretching out your fingers here from the pinky to the thumb. This is using your left hand. And over here with your pointer finger, going from the from the what I call the top knuckle to the bit of the finger is going to be 3 degrees. From the third to the second knuckle is 4 degrees, and then from that's the top. I guess the first knuckle would be the base knuckle, then the second and the third knuckle. So from the tip of the finger to the third knuckle would be 3 degrees. The third to the second knuckle is going to be 4 degrees, and from the second knuckle to the base knuckle in your pointer, that's going to be about 6 degrees of sky. So it's always, you want to try to navigate across the constellations without coordinates. You want to pay attention to the direction of the setting sun. Sun rises in the east and sets in the west. Some people look at a planisphere and they're confused about the orientation of east and west. It's different from looking at a map like Google Map because it has the east and west pointed in opposite directions. So from the setting sun, you look north, the setting sun is to your left and the rising sun is towards your right. And then of course it's flip-flop. It's in reverse when you're looking towards the south, where the setting sun is at your right and the setting sun is towards your left. We're looking south. So when you get confused about north, south, east, or west, that's a good way to remind yourself when you're, when you're trying to find your way. That way you know where north is, where east and west is located, and then that'll help you to find your constellations in the night sky. So watch the constellations in the night sky, look for the movements based on the cardinal directions, knowing where the sun rises and where it sets and how you view the setting and rising sun if you're looking towards the north or south. You move across the sky in increments of full moon widths and the rings of the Telrad, 1/2 degree, 2 degrees, or 4 degrees of sky. When you're not worried about using RA and DEC and you're not having nothing more than just basic motors to guide the telescope, or you just have a basic just point around scope just to look at objects without any basic tracking system. If you don't have just a basic Dob scope and it doesn't have any tracking gears or motors, if you're just using a basic Dob and you don't have like, if you don't have like SciTech or any type of guidance program, it's always good to use these techniques for star hopping to find your way around the night sky. And apply your nebula filters to your viewfinders or refractors of small aperture if you want to find those large emission nebulas for navigation. If you want to move between nebulas, of course, having very, very dark skies with low Bortle numbers always helps. So star hopping is the best way to start in astronomy. You get a simple star atlas, you learn about the constellations and the bright stars, you go out at night and find the famous constellations, you locate those constellations by their asterisms, locate and identify the brightest stars, and observe the changes in the sky from season to season because the constellations will change. Always navigate with your hands. You get a small scope and a parastronomical binocular. You move by increments with full moons or Telrad circles. Always get your bearings based on the cardinal directions because you can get lost at night. And just simply navigate your way with stars, with globular star clusters, with galaxies, and you get very good with the skills. You can actually hop between nebulas. I think star hopping is the best. Star hopping is the same as sky navigation. It's the best way for any amateur to start out in astronomy when they want to navigate around the sky and know where an object is. Because if you got your scope with a computerized system, driving the scope towards an area of the sky that you want to track, if a visitor looks to your telescope and say, "Oh, that's a nice object. Where is it?" Well, you want to be able to, not look foolish and say, "Okay, it's in that constellation over there next to that star, about 3 or 4 degrees to the northeast or southwest." So that's a combination of star, galaxy, and hopping between deep sky objects. And I hope everyone will be able to enjoy the sky. It can be a bit complicated when navigating around the Virgo clusters of galaxies, but you just have to do it time and time again for practice, and using the Messier marathon method for how they hop around around the galaxies in the Virgo cluster is the best way to navigate around any cluster of galaxies. And so that's my presentation.
So thanks very much, Justin. Really appreciate it. I just want to let everyone know that we also have seasonal talks online. We usually try to do a winter, summer, spring, fall talk, and that way we help familiarize you with some of the constellation shapes that are easy to see. And you pretty much go from familiar to less familiar as you're learning astronomy. Mm-hmm. I was surprised when I first got my 8-inch telescope. It was my first time to use a Telrad, what Justin was talking about with the red circles on the sky, no magnification. And I was surprised how easy it was to find many objects just by making triangles between 2 major stars in a constellation and then the object. And I really tried to get the exact shape of the triangle. Some of these Messier objects are bright enough to find it that simply. Just figuring out, okay, there's a Messier object, here's 2 stars, I can see what shape triangle does it make, and then zeroing in directly. But when you are looking for some objects, you need to start with more familiar or something that you can see and move towards something less obvious, as Justin told you, with all these various techniques. Do we have any questions?
I don't have a question, but I do have to make at least two observations. Without a doubt, one of the things that you said several times tonight, the best way to learn the sky is what you've outlined for us tonight. The books are great and videos are great, and you can learn a lot like that, but doing star hopping is, you're going to really learn the sky great and be able to appreciate it more. My second and last observation is that you showed us an awful lot tonight. And I think we could call that the McCollum Marathon, if everybody does what you just showed us tonight. And there should be a fantastic award if we could do, well, let's say 50% of what you showed us tonight. Very comprehensive. Thank you, Justin.
Yeah, I agree. So what Justin was showing us is what sometimes might do once or twice in one night. I'm looking for something difficult. He came up with all these ways, these signposts to get from a bright star to something farther away from it. And you wouldn't do all of what Justin mentioned in a single night. You might only do 2 or 3 of these in one night.
These are from years of experience, and some of these are my own sort of homemade techniques.
So completing the McCollum Marathon is perfectly valid if you do it all within 1 year. As far as I'm concerned.
And if you want something, and for some, if you want to, it's deepskywatch.com. They have very good sky atlases that give you a lot of deep sky objects and star patterns. And Stellarium, you don't need to buy a software program. And if you don't want to buy the Pocket Sky Atlas, there's actually a simpler version to Deep Sky Watch on their website. You can download it, you can print it up, and then you've got your atlas right there. That and Stellarium, you can do almost all the catalogs, almost all of them, all the observing programs with Stellarium and with Deep Sky Watches. Download their atlases to do most of the observing programs, enough to become a master or a very double master observer with the Astronomical League.
So Justin, is Stellarium a program that can flip the direction, so you see what you see in your eyepiece for your particular optics is the way it appears on Stellarium when you get the star hopping?
I think so. I think it does have that flipping feature. They have a lot more features than they've had in the past. There's actually a telescope feature where you can sort of flip the view of the sky depending on what type of telescope you're using. But if what I always do is that if you don't feel comfortable using the flip feature because it's not obvious, because it's a plugin that you need to download from the program and configure, what I would do is you can put up the coordinates for RA and DEX, so you can see where they merge towards the north and merge towards the south. That way, when you get the object, let's say on the meridian, you can know where north and west is. So you can flip the image upside down. You can actually do a screenshot of the image, put it something like on PowerPoint or let's say on Microsoft Word or some paint shop, and you can flip the image upside down and left, right, so you can know where the north, south is, how it changes, how east and west change, and how east and north changes with respect to different directions. And that way you get sort of a photographic view. And then when you go to observe it, you can see what the image looks like sort of upside down or, flipped in reverse.
Right. I've used paper atlases for a long time, and I've constantly had to flip things in my mind, like all those tests you do where you're flipping solids around.
You can flip it. Yeah, you can flip it, but with Stellarium, you can flip, and I think you can also reverse. It's a great freeware program. They got like 24 different catalogs now, so you can do almost all the observing programs.
Terrific. That's good to know.
And not have to spend a single penny. So
I see there's something in chat. Anybody want to make a comment from chat? Celsa? She says all the information is great, doable. Great tip about using the TELRAD. I always forget that you can measure the sky with a TELRAD. And yes. Brown, you're recommending Sky Safari, which can also flip.
Yes, so, it can flip and vertical and do both. I know Stellarium has that feature where you can flip and vertical. It's a standard now with a lot of programs, particularly with Sky Safari and Stellarium. But if you just want a conventional atlas, before you do all that flipping and so forth in the telescope, it's best to try to look at things based on the right orientation of north, east, and west. And that's just using the paper atlases. But
go ahead.
Well, like I said, it's deepskywatch.com. It's like the equivalent to your Uranometria, and you can download it. And it actually gives you supplementals where it has like tables and tables of objects. So you can do something if you don't have Sky tools and organize a lot of your observing programs that way.
You also gave us a lot of star names, some of which I've always known the star by eye, but I actually did not know the name yet. So Linda Sternbach mentions that an iPhone is a great tool to learn more star names just by pointing at the sky.
If you don't know the star names, it's not important. It's important to know just a few names of the brightest stars. So it's important is looking at, okay, here's the Great Square Pegasus, but I don't know the names of the star. So I say, here's the northeast star, here's the southwest star. And from there, I go to these triangles of stars. Here's the head of the horse of Pegasus. Here's the tail of the horse of Pegasus. Do it that way, right? Before you try to learn every star. Because there are actually, Stellarium has hundreds of names for stars in the night sky from thousands of years of astronomers, Arab and Greek astronomers naming the stars in a constellation. They usually represent a body part or a piece of an instrument for the name of a star, for a part of a constellation.
Any other comments or questions?
And I notice how Manuel Luther here mentioned that it allows you to view through specific eyepieces. That's true. You can put in your telescope, the features of the telescope. You can look at different eyepieces at different powers. There's even the equivalent to having a bifilar micrometer simulation, where you're going to have these sort of the coordinates around it. So you can point out positions where comets are moving across the sky and look at changes of how the comet is progressing and look at the movement across the sky by, let's say, degrees per day. So I know Van Slyke's instruments no longer exist, but if you want something like a bifilar micrometer as a simulation, you can upload your astro images onto Stellarium and then use that to sort of look at objects moving across the sky, use your bifilar micrometer in the sort of the ocular plug-in where you get the TELRAD, and then that's where it fits right there to where you can simulate what the sky will look like in your telescope. But you got to put in the features for the telescope, for the eyepiece, and you can also do that for your imaging equipment as well, for your digital camera.
That's terrific to know. So I also see in the chat that I'd like to answer the question for everybody that all of our talks that are recorded end up on our website later on and are sometimes on our public Facebook page for a while also, that you can rewatch them. So also, if you're new to astronomy, there may be some things you need to know other than what we talked about just tonight. We have many recorded talks about telescope optics or how to navigate the sky in general, all of the seasonal talks, how to use a certain type of telescope. You can go to HAS recorded presentations after you log in anytime and watch anything you need to watch there. So I'd like to thank Justin very much for your talk tonight. Really appreciate it. He did a couple of other talks tonight that are this month. Sorry, I should say this year in the last few months that we can also rewatch. And if there are no more questions, I guess we can go ahead and end the meeting. So I'd like to thank Justin again, and I'm not a co-host. I think we'll have to ask Steve Goldberg maybe to end the meeting, and hope to see you next time in December.